Hey, hi everyone. So first of all, who am I? I maintain vLLM full-time on behalf of Hugging Face. And if you've seen the profile picture of a goose with a raspberry for a body on GitHub, that was me. And if you didn't know that that's what that was, this is the first thing you've learned from my talk. So this talk is for the creators of open source LLMs, the post-trainers of open source LLMs, and the general tinkerers who just might be interested in trying things. So if you're creating an LLM, then it's extremely likely that you'll be creating a Hugging Face Transformers implementation of it. It's kind of a natural decision because these implementations are the most interoperable and portable for both you and your users. If an application or a package includes the from pre-trained method, then your Hugging Face Transformers implementation can be used there. If you're post-training, it's also quite likely that your starting point might be a Hugging Face Transformers implementation, and that your RL library might use vLLM for generations. And this requires your architecture to also be supported by vLLM as well as your training library. And until recently, vLLM wasn't one of those packages where you could load arbitrary models using from pre-trained, which meant that as a model builder, you had to learn how to implement your models in both frameworks. So for vLLM, for some of the more advanced features, that could be a little complicated for a novice for features like expert parallel load balancing or pipeline parallel or LoRa. And then you would have to implement the model in transformers as well, assuming that you're planning to release it there in parallel. And you'd have to keep these implementations in sync for the entire development lifecycle, so pre-release while you're still refining the architecture, through to post-release where you might be fixing bugs or updating APIs that may change in transformers or vLLM. And so if only there was a better way. So enter the transformers backend, and this allows you to only maintain a single modeling code base. Sorry, I've been blinded by the lights. And this adds vLLM to the long list of places where you can use this universal modeling implementation. And it automatically gives you access to the more advanced features, like the ones I mentioned earlier, because these are built into the classes that are added for the Transformers backend. So what does it support in vLLM? So on this slide, you see all of the model-specific features which have been added in the Transformers backend. So for attention, it supports encoder attention, decoder attention, sliding window, interleaved sliding window. We support dense and mixture of experts MLPs. We support text and image, video and audio are being worked on and coming soon. For pooling, we support embedding and classification, and also vLLM's pooling adapters. And for parallelism, we support data, tensor, expert, and pipeline in any combination that your particular architecture might be usable in. And it's also worth noting that while these are the model-specific supported features, if your model does anything unusual in between these modules that vLLM dictates, like the attention forward pass or the fused MOE, then they'll just work because we call the forward pass on the transformers implementation. So, for example, if you have a novel expert routing method that vLLM doesn't support, with the transformers backend, it should just work. And now I know that it supports a bunch of things, you would want to know if it's fast. So on limited benchmarking of a small MOE model, we saw less than 3% reduction in throughput and almost no change in latencies. And from limited anonymous usage stats collection, which are usually disabled in production, we can see that this feature in Q3 was used for over 4 million GPU hours. So it's clearly fast enough for some. So how can you use it? If you just want to try a model that already supports this in Transformers, then you simply add this flag and look for the using Transformers backend log in the logs. For a new model, you would write your Transformers model implementation as normal, following the Hugging Face docs, ensuring that it's accessible to auto model. So if you're upstreaming your model, which is recommended, because if you do that, then the Transformers team will be able to make sure that it is updated and optimized and bug fixed as Transformers develops. And so if you are upstreaming, you'll want to make sure that it's added to the helper functions in the auto directory. And if you are using a custom code model, you'll want to make sure that your base model, which is the model without the language modeling head, and the config class are both added to the config.json in the auto map field. So once you have that base transformers implementation, you'll want to make sure that you're using the all attention functions global variable. In transformers, this is normally used for adding flash attention, flex attention, SDPA. But with vLLM, what we do is we add in vLLM's attention implementation into this global variable so that you can get support for KV caching and all the parallelism features that we love about vLLM. And once we've done that, we also need to make sure that from the forward method of the base model, the keyword arguments are passed all the way down and into the attention interface once it has been selected. To add support for all the parallelism schemes that I mentioned earlier, for tensor parallel and pipeline parallel, you will want to make sure that you annotate the config with these two plans. For tensor parallel, we're just saying which layers should be sharded and in which orientation should we shard them. For pipeline parallel, we're saying which layers are not on every rank and in which order should they be executed. And for expert parallel, which is also technically a prerequisite for supporting fused MOE, you just want to make sure that the MLP includes an experts attribute and that forward is called directly on it rather than, say, in a for loop if you have lots of individual linears as your experts. So, in summary, making the transformers model compatible with vLLM is super easy via the transformers backend. The throughput performance difference is negligible, and we are aware of a couple of places where we can close that gap further. And your single, now vLLM compatible model implementation is also compatible with all the training engines like Unsloth, Torch Titan, Axolotl, etc. Compatible with most quantization algorithms and easily testable locally using libraries like Transformers, Candle, GGML, or your library of choice for running Transformers models. So, and that's all. Does anyone have any questions?
Anyone in attendance have any questions for Harry while he's on stage? Any questions out there? We got one.
Yeah, that was amazing. I guess I was wondering, is this available anywhere in like docs or like a blog or something?
Sorry, I'm struggling to hear you over the...
Is this available anywhere in like blog or docs or something? Because I'd love to see it again.
So all of this is supported on the main branches of both vLLM and Transformers. Mm-hmm. Caveat being that because of Transformers v5, which is in progress right now, the latest commit isn't currently compatible. There's a particular PR that you have to check out main branch before for it to continue working, but maybe by the time you try it, I will have fixed it because I have a PR open right now. So yeah, just main for both packages and you can give it a go.
Thank you.
One more question here.
Another question on backward compatibility. What happens to all the existing transformers models? Can you make like those that were implemented using earlier versions of transformers? Right? Can we make them work with vLLM by doing this upgrade?
Sorry, I didn't hear that either. It's really...
yeah. Backward compatibility with other transformers models that is existing in Hugging Face repository so far. What happens to those? Can we make them vLLM compatible? Yeah, it's okay.
Sorry.
Any more questions out there? If you do have more, we may just take the rest off stage since our next talk is in a few minutes. All right. Thank you so much, Harry.
Thank you.